Well, hey there, everybody. It's your boy, Mr. Perry. And here we go. We are at Unit 7, Lesson 5. We're going to finally start branching away from learning specifically about array lists. And we're going to start getting into the searches and the sorting methods that we learn in this class. So today, we're going to get into linear versus binary searching. And if you took AP CSP, you've already learned this concept in an abstract sense. However, for AP CSA, we're going to be learning this more from the standpoint of programming and really understanding how these are programmed, and then how they work with arrays as well as array lists. So let's just do some general review and do a general overview first. What you need to know going into this lesson is that both linear and binary searches can be performed on arrays as well as array lists. So they work with both of them. In Java, there is an algorithm for a linear and a binary search, which we need to become familiar with. Now, you should be able to memorize and know the algorithm for a linear search. However, for a binary search, you should just be able to recognize the program code and understand, what it is and how to trace it. So you don't have to memorize the code for a binary search, but again, you should be able to recognize it when you see it as a part of, one of your questions. You should be able to understand how it works, and you should be able to trace the code. So that's, basically what you need to know going into it. So let's start talking about what is a binary search. So one of the examples I use in AP Computer Science Principles is I ask a student to pick a number between 1 and 1,000, and I always tell that student to pick something that's kind of on the high end. So we can just kind of start with that. Like, we'll just assume somebody has picked a number between 1 and 1,000. Now, if I wanted to do a linear search, what I would need to do is I would need to start at the beginning and basically check every single individual element the entire time. So I would ask the student, is it number 1? And they would probably say no. And then I would say, okay, is it number 2? And they would probably say no. And then I would say, is it number 3? And they would probably say no. And then at that point, we would stop. And I would ask, okay, so am I guaranteed to find this student's number? And of course, everybody says yes. The answer is yes, I will get there. The problem is, it's just going to take me a really long time. But with a linear search, as long as your target appears up here somewhere, you are guaranteed to find it. If it appears early in the data set, you're going to find it quickly. If it appears later in the data set, it's going to take you longer to find it. And that's just basically how it is. So the linear search is easy to code, and it's also easy to understand. The linear search really only works for small data sets or when your target appears early in the data set. And the one thing that's good about a linear search is it does not matter if the elements are in any kind of order. If it's a array or an array list of integers, they can be in any number, in any order, and you're guaranteed to find it if it's there. And if it's an array or an array list of strings, again, they don't have to be in any order. You can use a linear search, and if the target appears in it, then you're guaranteed to find it. So let's take a second here, and let's go ahead and look at the program code for a linear search with an array, and then we'll do the same thing for an array list. So here's a method, a public int linear search. And so this is going to return the integer representing the index value of the target number that you're trying to find in this array. So we've got two parameters here, an array of integers called array, and then we have a target, something that we're trying to find. So what's going to happen is we're going to need to loop through the entire array. So I've got my for loop header here, and then I need to check if each individual index of this array is equal to my target. So if array at index I is equal to the target, so if the target is found, it should return I. It should return the index of where the target appears in my array. So that's what the return I is doing. So, and then of course, if it's not found, if array at I is not equal to the target, then it skips everything between these two curly braces, and it basically just continues with your for loop. And so the for loop keeps going until the array at index I is equal to the target, in which case it returns the I. But what if the target does not appear in the array? Well, if it loops through the entire array and never finds its target, then ultimately it's going to return -1. So if it's not found, it returns -1. And since -1 is impossible to be the index of an element in an array, then that means it's obviously not there. So let's go ahead and look at how we would do this for an array list. Let's modify our program code here. And as you can see, it's the same basic setup, public int linear search for an array list of integers called list. And again, we're looking for the target. We just need to loop through the entire list. And again, we're using the list.size. And then it says if list.getI is equal to the target, return I. And then again, if we loop through the entire thing and we don't find it, then we're going to go ahead and return -1. So there you go. That's the linear search for an array list. So hopefully that made sense. It should be a pretty easy one. Now we need to look at the binary search. And this is the one that's a lot more complicated and has got a bit more going on. So let's go ahead and have a look at how it works. So basically a binary search, the goal is to cut your workload in half each time using math operators. And the way we're going to do it is we're going to do this. We're going to calculate the midpoint between the first and the last element. So we got to figure out what is the midpoint between the first and the last element in the array or array list. Then we need to check whether the target is greater than the midpoint, whether it is less than the midpoint, or whether or not it equals the midpoint. Now, of course, if it equals the midpoint, that means we've found it and we're good to go. But if it's either greater than the midpoint or less than the midpoint, what we have to do is we have to adjust the first or last element that we're searching depending on the outcome of step 2. So this will make more sense in a second here, but just kind of take note of the 3 steps. Calculate the midpoint, check whether the target equals the midpoint, whether or not it's greater than the midpoint or whether or not it's less than the midpoint. And then again, we have to adjust. Depending on the outcome of this, we have to adjust either the first or the last element. So let's go ahead and look at, in a general sense, how this would work. So if we go back to my earlier example, and again, let's assume that I have a student who's chosen a number way up here at, we'll just say it's like 990, all right? So what I need to do is I need to calculate the midpoint. Well, what's the midpoint between 1 and 1,000? 500. And I would ask the question, is it greater than 500? So the student would say yes. So what that means is I can now move my starting point all the way to the middle because I know basically the first half of this, what I'm looking for is not there. So I'm moving my starting point way up here to 501, and now I'm going to ask my next question. I have to calculate the midpoint between 501 and 1,000, and we're just going to call it 750. So I would now ask, is it greater than 750? And again, the student would say yes, which means I need to adjust my starting point to 751 because I know it's greater than 750. So I would do that. And again, the midpoint is 825. So I now have moved my starting point to be 826, and now I'm going to ask, is it greater than 825? So is it between 826 and 1,000? And this would basically repeat until I finally land on the target number. So again, what I did each time is I calculated the midpoint, and I checked whether it is greater, less than, or equal to, and then again had to adjust either the first or the last element depending on what the outcome was. So the binary search is a bit more challenging. However, the binary search works very nicely for large data sets because it eliminates 50% of the potential workload each time by examining the element in the midpoint. Now, the only thing is, though, a binary search only works if your elements are in order. If you have an unsorted array or array list, If it's numbers or strings, if it's not sorted, if it's not in numerical order or alphabetical order, or even reverse numerical order and or reverse alphabetical order, if it's not somehow ordered, then the binary search will not work. So let's go ahead and have a look at our program code here. So here we have a method called public int binary search. And again, the goal is to return the int representing the index value of the target number we're trying to find in this array of integers called array. So the first thing we're going to do is we are going to choose our starting point and our end point. So we're going to start with the starting point being 0, and we're going to start with the end being array.length minus 1. So now we're going to look at the very first element and then the very last element. And int start and int end, both of these variables will keep track of which portion of the array is being searched. So right now we're searching the entire array because we're starting at 0 and ending at array.length minus 1. Now we're going to go into a loop. And we're going to say while start is less than or equal to end. So as long as my starting index is less than or equal to the end index, then we're going to go ahead and start doing what we need to do. So the first thing we need to do is calculate the midpoint. And this is going to represent your guess. So int middle equals start plus end divided by 2. So that's going to take 0, and then it's going to take the index of our final element. It's going to divide it by 2, and then that's going to give us our midpoint. So we now have our middle. Now we're going to get to the next portion of this code, which is all down here. If the target is less than the array at middle, all right, so this is checking if the target is less than the midpoint. So in other words, if you guess too high, then what we need to do is we need to move the endpoint to be middle minus 1. Because again, if I guessed, is it greater than 500, and it turns out, or I'm sorry, if I guessed, is the number less than 500? If the answer is yes, then I would need to move my 1000 to 499. So that's what this is doing right here. If the target is less than the array at middle, so again, if the target is less than the midpoint, in other words, if you guess too high, we've got to move the end to be middle minus 1. We have to take that endpoint and move it way over here. Now, if this is not true, then we're going to look at your else if, and it says else if the target is greater than array at the middle. So if the target is greater than the midpoint, or in other words, if you guess too low, all right, well, if you guess too low, then you need to move the starting point to be the middle plus 1. So that's what we did before. Instead of starting at 1, I moved it all the way up to 501, right? Because again, if I guessed too low, then that means I could eliminate the bottom half. So that's what we're doing here, is we're moving our starting point to be middle plus 1. Now, if the target is not greater than the array at middle, and if the target is not, if the target is not less than the array at middle index, and if the target is not greater than the array at the middle index, then that means you found it. In which case, we need to return the middle index, because that means, again, you actually, whatever the middle index was, that actually was the answer. And then this loop continues. So depending on the outcome, again, if you find it, then you just return middle and it's done. But if you were too high or if you were too low, then you stay inside the loop. And remember, this is looping as long as the starting index is less than or equal to the end index. And so, when you stay in the loop, what's going to happen is it's going to calculate the middle again with either your new start or your new end index divided by 2. And then again, you're going to check whether or not it is less than or greater than, or whether or not you found it. And again, if it's either less than or greater than, you adjust the end or the start to be middle minus 1 or middle plus 1. And again, you stay in your while loop. So as long as start is less than or equal to the end, recalculate the middle. Hopefully you're seeing how this works at this point. Now, if you go through the entire array and you don't find it, then obviously you're going to return -1 because if it's not found, that's what you do. So that is the binary search code for arrays. If we adjust it for array lists, it's going to look like this. Public int binary search with an array list of integers called list. And again, a target that we're trying to find. We'll go ahead and figure our initial start and endpoints to be 0 and list.size -1. So this gives us our starting index and our final index. And then the same thing happens while start is less than or equal to the middle or end. Calculate your middle and then check whether or not the middle index is less than the target. And if it is, then you guessed too high. So you have to adjust your end to be middle -1. Now, if that's not true, you see if the list in the middle is greater than the target. So if you guessed too low, ooh, shoot, I'm just realizing there's a mistake here. This should say start equals middle -1 because it should, oh, shoot. Well, I'm going to have to fix it and redo the video. But anyways, let's go ahead and fix it right now. Why not? We'll fix it mid-video. That's bad form, but hey, there we go. So now we are checking if list.getMiddle is greater than the target. And if it is, again, we've got to reposition our starting index to be middle +1. And then if it's not this, then our else says return the middle. That means we found it. And there you go. Again, this would just continue looping until you either find it, or if you don't find it, you return -1. All right. There is another really good video with animations that shows how the binary search works, and I'm going to link it to this video as well. I'll link it to this assignment. Highly, 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 highly recommend watching this. Start it, skip it to 2 minutes and 12 seconds into the video, but it's definitely worth your time to see this program code done with proper animation. So I'm going to skip it. We're going to just going to remind you of a couple of key things here. If you want to recognize the binary search, you really need to pay attention to a few key lines. If you notice that you are calculating the middle index by starting, by checking the start plus the end divided by 2, then this is a good indication that you're looking at the binary search. And then another couple of key lines here is when you recalculate your endpoint to be middle -1, or when you recalculate your starting index to be middle +1. So again, if you see these, then this should be an indication that what you're looking at is the binary search. All right, well, with that, we're going to do a little bit more practice with this in class, but hopefully you get a good sense of how the program code works. Thanks for watching. Make sure you leave a question or a comment about today's video, and I'll see you in class.